Is this better?
No yet.
Ooh, all right, better now. So I was just saying, it's amazing to kind of see all these things about art and economics and sociology that, quite honestly, we don't think enough about in kind of the technology space. So I'll just say a little bit about kind of some of the things that I work on day to day. I'm one of the co-founders of a small startup called Computable. We're a team of 9 people, soon to be 10. Our goal really is to build a decentralized data market. Now, that's a lot of jargon in like 3 words right there, so I'm going to try to explain why you should care about decentralized data markets and why that's kind of interesting.
The down arrow.
Yeah, the down arrow.
The down arrow?
Yes.
Ooh, wonderful. So here is a very kind of rough pictorial idea of what a decentralized data market is. Imagine that there's a bunch of people who have information that they'd like to share. You can imagine this is a company. For example, I have lots of friends at biotech companies, and anyone who's done work with biotech knows that there's a lot of things in human biology that are hard to figure out. Someone might have tried to make a drug for a particular target, as it's called. And usually these things don't pan out, and it's kind of a loss for the company. And they just kind of wish there was a way to monetize or make up for that loss. Or companies in, say, the consumer ads or customer data type situations, they want to say, hey, we have some data, can we blend that with other data? Can we get other things to do with it? Or, thinking more scientifically, perhaps you're a lab that has a laser device that I have a friend who spent 5 years building one of these for a PhD. And you took a lot of measurements with it, but that science paper didn't go through and you're not entirely sure what to do with it. You just put it up maybe out there on the internet. On the other side, there's a lot of people who wish they had data. You could have scientists trying to build kind of machine learning models. You could have companies trying to do big data and all that. You could have people just looking for plain old information, things like analysts versus stocks. So you can kind of view this as a market. There's some people who have data on one side. There's people who want data on the other side. And as of right now, there's not really a good way to connect the two. In fact, this is something that a lot of the big companies are starting to think about. So just last week, Google announced something they're calling a data set search. So essentially, there's a new type of Google search where you can search for data sets that are related to the problem that you care about. Now, this is cool, this is neat, but usually the only things you can find on there are basically scientific data sets that someone put out there. So I help run an open source project called DeepChem. It's deep learning for chemistry and biology. So we maintain a collection of chemical and biological data sets. We're probably going to try to see if we can put that and format it so it'll pop up on Google search. But these are kind of academic data sets that we as scientists sort of put out there anyways. So the question is that what if you have all these non-academic data sets? Maybe someone did a lot of work trying to gather that data. Maybe they want to get paid their fair share for it. How do you connect those types of data sets to people who'd like to have them? That's not a problem that Google right now is trying to solve. But it is a problem that we're trying to solve at Computable. So one of the reasons we kind of want to do things like this is we want to enable kind of uses of data science in places that it's really not feasible to do today. So one of our engineers, she put this slide together. She used to work at a smart IoT company. I think they made a better light bulb or something like that. So she'd work on data science servers. She'd find that a lot of kind of the models they try to make, there really wasn't sufficient information to start applying these models. And actually, if you work in something like the self-driving car industry, you can find at times it's actually relatively challenging to gather the data you need. So I think Baidu, for example, they have started something like a 5,000 person self-driving car data annotation team where they have 5,000 people literally annotating data so they can start building self-driving cars. So getting access to the information you need to kind of build a new type of machine learning technology is actually this giant, giant effort. All the big companies have their own internal warehouses to do it. If you're a relatively small company, you might be out of luck. It might just take more effort than you can personally kind of muster as a small company to make these things happen. So that's something that you could potentially solve if there were a market for this type of data. The other thing that, this is kind of a more personal issue that you run into as a data scientist. When you start kind of entering data science or physics, you will think that you're doing a lot of glamorous, fancy equations. So you think your world is like the pictures on the left-hand side, fancy, fancy math. What actually happens is you import Python and you start doing all sorts of really boring and kind of janky cleanup work. And the fact is that there's a lot of information in the world and there's a lot of information that's computerized. Most of it is really messy. So learning how to clean up data, basically do data custodial services, is actually what a lot of modern science ends up looking like. For example, I've worked a lot with protein crystal structures. So you'll have these things that are amazing scientifically, three-dimensional pictures of atoms, essentially. Unfortunately, what will happen is that entire parts of the protein will drop off. So you'd have all sorts of things like the hydrogens would be gone, or like you'd have atoms that existed in the same spot, according to the picture. Oh, wait, no, that oxygen, that nitrogen can't be on top of each other. So you actually have to do a lot of work in order to kind of filter out this data and clean it up. And at the end of the day, you typically need to call in an expert or someone who deeply understands that problem. And again, this is the sort of thing that's like this unpaid munch work that right now is kind of done by understaffed grad students. There's a lot of professors in the audience. I'm sure that your grad students can tell you about all the sorts of things that you end up having to do to make research work out. And since I just came out of grad school, very fresh in my memory, these things. So another kind of thing you start thinking about is how can you begin to stretch the boundaries of AI? So anytime you want to apply machine learning to a new space, you essentially need a new source of information. And as for each type of new data that's gathered, that kind of makes it feasible to do new types of learning. For example, Fei-Fei Li's group at Stanford gathered the ImageNet dataset. People have used that since to basically train computer vision models that have been applied in hundreds of companies. Part of my work at Stanford, I helped gather a data set called MoleculeNet. It's a collection of molecular machine learning data. And not hundreds, but at least probably a couple dozen companies have used these models to kind of build better chemical systems that they can apply machine learning in. And each time you get a new data set that's cleaned up and put out there, that really makes a new type of machine learning start to come to life. So when you can start to do new machine learning, there's all sorts of interesting things that you can do. There's a lot of interest, lots and lots of software developers and scientists are really trying to get into machine learning. That's a book I wrote a while back on kind of applying TensorFlow, a new Google library for machine learning. So there's a lot of interest, like even lots of books floating around, lots of people trying to switch into this career. So you can tell there's a lot of interest and a lot of like excitement. But then for the reasons kind of data's messy, data's not there, takes a lot of effort, it actually turns out that machine learning has comparatively less impact than you might think it would. There's kind of a joke that most of the things, when you think you're doing machine learning, you think you're building Terminator. What actually ends up happening if you're anywhere in the real world is that someone hands you Excel and you like kind of munch with it for a while and you go back and make a PowerPoint presentation and talk to people. That's not terrible, but it's kind of really not the potential, achieving the full potential of the technology. So I'm going to take kind of a brief detour before I kind of come back to the data science aspect and tell you about another kind of very interesting strand of technology that's kind of coming to fruition. There's this other system that's called Ethereum. How many people have heard of, say, Bitcoin here? Just about everybody. How many people have heard of Ethereum? Fewer people, but Ethereum and Bitcoin are basically what you might call blockchain systems. The core idea is that there's a network of computers that essentially synchronize their state to make sure that they all have the same internal state. Now, this is really useful when you want to make a ledger. If you want to make sure that we all agree on who owns how much money, like, Joe has 10 whereas there are 10 Bitcoin, and Bob has 5, and Alice has 3. You want to make sure that all the computers in your network can agree on that. That's kind of the core of Bitcoin. Now, I know some Bitcoin enthusiasts who get very mad at me for reducing the system to that, but it's not actually a terrible analogy. Now, Ethereum is a little more tricky. It's when you start thinking about, can we put contracts and rules and kind of interesting systems on top of this money? Like maybe I want to say that, can I take out a loan against my next month's paycheck, which is likely to come in? Can I make a contract for that? It turns out that you can on Ethereum. There's actually these programmatic tools called smart contracts that you can essentially stitch together to start doing all these interesting things like raise money for a new idea, or you can take out a loan, or you can like make an index fund. And all of it's kind of traded programmatically on these so-called smart contracts. So there's this really interesting idea where the systems like Bitcoin and Ethereum let you take traditional financial infrastructure and put it up essentially on this network of computers. And the idea is that the sanctity of the contract is enforced by the network of computers for the same reason that we all agree that Bob has 10 Bitcoin. We can also all agree that Joe's loan should come in, say, next week, for example. Now, there's a lot more technical details involved in making this happen, but kind of the idea is like, let's synchronize a bunch of computers. Let's get them to agree on common facts and also common contracts. And you can begin to do some interesting, curious things. For example, one of the cute applications of kind of blockchain systems out there is these things called CryptoKitties. So has anyone ever played with things like Neopets back in the day, or Tamagotchi? Yep, definitely a few people. So you can think of CryptoKitties as the next gen version of that. So you can imagine that instead of us all agreeing on the contents of ledgers on these computers, we can all agree instead on these little virtual kitties. And the idea is that we can all agree that this person owns this kitty, and this kitty looks like so-and-so. So this is kind of one of these minor internet viral crazes that went around a few months ago. And there are these CryptoKitties, some of them actually sold for like tens of thousands of dollars, which is ridiculous, but you'd be surprised at what rich people that are bored will spend money on the internet. So there's a lot of other interesting applications you can begin to cook up as well. Another thing you can begin to do is start thinking about, can you take things on the internet that we all look at, like I think many kind of professors and academics here, so US News rankings, we all know how important those are. My little sister goes to Carnegie Mellon for computer science, and she was telling me they just moved up to #1 on the rankings. All the professors are walking around like they had wings on their feet, like, yeah, well, let's give a round of applause for Carnegie Mellon. So you know how important these things are. But is that ranking really meaningful? Like, is Carnegie Mellon really better than MIT today, and MIT was worse yesterday? Who knows, possibly. But there's really no clarity on these things. It's kind of an opaque system. Like the US News editors have some system, we don't quite know it. They tell us something that seems to match reality, so we usually go along with it. But there's no kind of visibility into it. Another kind of example of this is the Google search algorithm. Now that's a mighty, mighty system out there, kind of makes and breaks entire dynasties. What kind of goes in Google search? So I had a mentor, I worked at Google for a while, who used to run part of the Google search team. There's something like 10,000 different subsystems going in there. Nowadays, part of it is deep learned. We barely understand what goes in these systems. We certainly can't audit it. And I could probably, from first algorithmic principles, tell you how the algorithm is derived, but I can't really explain how it functions. So you can kind of imagine why it's bad that these things are not more visible. So an interesting idea that you can begin to construct is, what if you can take kind of contracts or systems like this and instead kind of make them open source? Have their kind of core logic be put up and be publicly auditable. You can start to construct these essentially decentralized systems. For example, here's a very simple system. This is made actually with Computable's toolkit of how you might make a little decentralized version of the US News ranking. And the basic idea is you have a voting system. You have a bunch of reviewers who kind of log into a little system like this. And you can make votes saying that, oh, rah, I think that Georgia Tech is actually the best computer science school out there, or Stanford, or Carnegie Mellon, or Arizona State, who knows? Actually, I think we have an even weirder set of colleges on here, but maybe Miskatonic U is actually the true computer science school. But you can kind of put down your vote, and the system kind of follows the voting dynamics that are specified. And that actually is how the rankings are derived, basically by election. It's perhaps not as efficient as having an editor at US News put something down this year, but it's also dramatically more auditable. You know, there's a set of votes. The contract system guarantees that your votes did what they were supposed to. And you know that whatever's up there represents kind of the vote ranking that people voted on. So there's kind of a fairness to these systems that begins to be interesting. So there's actually a little kind of peeking behind the curtain into how these systems function. So here's a picture of what a smart contract actually looks like. And the interesting thing is that when you can take these smart contracts, we can kind of now come back to the original part of the story about why you want a decentralized data market. Well, what is a decentralized data market? You want buyers and sellers of data sets to talk to each other. Core idea, make a bunch of smart contracts that enforce the rules of the marketplace. So that's kind of more or less what we're doing at Computable. We want to build this type of decentralized data marketplace. We want to use it to enable greater applications of data science. We want to enable kind of more interesting use cases in AI. And we're doing so by building a series of smart contracts that allow you to construct these systems. So kind of as a final parting word, I'll say just a couple words about something I call AI native blockchains. Now, there's again a lot of buzzwords in there, just the hype. You can feel the hype. But there's actually something interesting. When you start thinking about AI, when you hear people say that their company does AI, that doesn't actually mean what you think it does. You're probably thinking Wall-E when you hear the words. Don't think Wall-E. Think like that. Think like how you draw a straight line given a bunch of dots, like regression. That's actually what most people mean when they say AI. But you can kind of begin to think about how can we build something that actually is a little bit more like Wall-E or like an organism that's responsible for kind of paying for its own upkeep, for making its own money. You begin to kind of think about what would the environment in which such an organism could emerge look like. You'd want some type of virtual world in which you could earn money and kind of spend money. That world kind of looks a little bit like the blockchain. This is sort of a trippy idea, but it's a trippy idea that has a lot of people excited and a lot of people thinking about it. So I think if you should pay attention to the blockchain, because I think that it's one of these ecosystems where you might begin to see very interesting new things emerge and have a synthesis of a lot of ideas that are floating around about how organizations are structured or how learning should be done or kind of the next generation of business. So with that, I think that's all I have today, and thank you all for listening.